So here's a problem, truss problem, and we want to find all the forces in the truss. So if you count them up, as we did a minute ago, there are 7 forces to find and 3 reactions. So we've got some work to do. So let's first start with a free body diagram of the whole structure. I think to save a little space, if you'll allow me, I'll just use the given drawing as my free body diagram, and I'll indicate what direction I think the reactions at A are and the pin here at E. So how do I find those? What should I do first?
Some moments around A.
Yeah. Good rule, kind of always some moments about the pin, so we'll do that. Again, I'll assume right-hand rule for my sign convention. So let's sum moments about A and set it equal to 0. So let's look at EY. With my sign convention, EY creates what kind of moment about A? Positive or negative?
Positive.
Positive. So there's the force, EY. The distance is 4 meters. And then out here, I've got this force P. It creates what kind of moment?
Negative.
Negative. So P. And it has a moment arm of 8. So not a complicated equation. So EY is simply going to be 2P. Okay? So now we'll finish this up by summing forces in the y direction. That should allow us to compute a value for AY. So summing up all my forces, AY and EY are both up, positive, and my force P is down. So when I solve for AY, I get minus P. Again, the seesaw analogy we talked about before, if you think this point E is kind of like the center of your seesaw, if you're pulling down P on this side, you better be pulling down P on the other side to balance it. And that we got that result, so that seems reasonable. And then last, for the free body diagram of the entire structure, we'll sum forces in the x direction. And again, this is pretty easy equation to solve. We only have one force, so by equilibrium it has to be 0. So we have 3 of the 10 unknowns pretty fast. So now some strategy comes into play. Which of the joints A, B, C, D, E can we start with?
D.
Can we start with D? Sure. There's just 2 unknowns there. Can we start at C?
No.
1, 2, 3. So the same can be said for B. 1, 2, 3. A, that's okay. Yeah, 2. E is the worst place to start. Right? So don't go there. So we either go A or we go D. Pick one. A. So let's do a free body diagram of joint A. And hang on, it'll take me a second to draw this. Hang on. Okay, I got it. There's A. No force in the x direction. There's a force in the y direction. It's down, and it's equal to P. Now I look at the force in the bottom chord element, so that'll be the force in AE. And then I have this upper chord element, which is the force in AB. And what is this angle? 60 degrees. Now I will make one comment about the way I subscript my forces. Sometimes in physics, when you say force AE, it means it's the tail is at A and the head is at E. It gives the direction of the vector. I don't do that. I just do it alphabetically. Because I'm always I know what direction I'm going. I'm always going to assume tension. So I don't let this bother me. So force AE, force EA, to me, same. Okay? Now, if you get over there and they require you to keep track of it that way, please do. And if you want to keep track of it here that way, please do. I just don't want that to be confusing down the road. This looks very familiar. We've seen problems like this before, maybe in our previous example. So what's the best thing to do? Some force is X or some force is Y? Y. Some forces in the Y direction, only one of our forces has a Y component. Right? If we sum forces in the X, we get an equation with two unknowns. So let's start with summing forces in the Y direction. I'll assume up for positive force. So I have my my X component, my Y component of AB will be FAB sine 60. That's acting up, and then I got P acting down. So I should be able to find the force in AB. It looks like it should be positive. It should be P over 2. I don't know what the sine of 60 is. What's the sine of 60? That's 0.5, isn't it?
That's
0.866. I knew. Okay, so it's 0.866p. Right? Is that what it is? No, wait. You divide by 0.866. So what is 1 over 0.866? 1.15. And it's positive. So that means AB is in tension. So now I can sum forces in the X direction. So looking at my free body diagram, I have the force in AE. It is positive. And the X component of AB is also positive. And that X component is the cosine of 60. So plug in your 1.15 in there, take the cosine of it, and that should be the value for AE. It looks like it's going to be negative. What's that value?
0.58.
0.58. Anybody else get that? So what's 1.15 times the cosine of 60? 0.58? Is that what you said, Mr. Lynn? Anybody else get that?
1.15 times cosine of 60 is 0.5.
Just 0.5?
0.575.
Oh, 0.575? Did you get
0.58.
Oh, he rounded. Okay, 0.58. I'll write 7.5. That's not a big problem. All right, let's stop and think what we've got here and see if it makes sense. So AB is in tension. Does it make sense that AB would be in tension? Well, when I pull down on this, I think it does make sense. It's kind of a gravity load. This whole top cord is probably going to stretch. It says AE is in compression. I think so too, because this E is going to move which way? Probably this way. So it will compress. When you pull down, it's not going to go that way, right?
Right.
It's probably going to go down to the left. So this one's going to move to the left, this will compress. So I bet you this one's going to be in compression, and that's going to be in tension, and that's going to be in tension. I don't know what the diagonals are going to be right off the top of my head. I'm guessing compression, but we'll see. So now I got 5 things, 5 to go. And just so we can keep track of them, I'll put a little squiggle in there that we've got those 2. So where can we go now? Can we go to E?
No.
Not a good choice. Still 3 unknowns. Can I go to B?
No.
Yes. I know AB, so I have only 2 unknowns. Can I go to C?
No.
No. Can I go to D? Yes. Which one is the easiest one? D. It doesn't include any previous values either. And if you look at D and you look at A, they're going to look very similar. In fact, this problem looks like it has some symmetry in it. So let's see if it's true. So I'm going to draw my free body diagram for D. There it is. I'm going to put my forces on it. P is acting down. I've got a tension force in DE, and I have a tension force in CD, and the internal angle is 60. Look at those two free body diagrams. They're just mirror images of each other about the y-axis, right? So I bet you if we sum forces in the y here, we're going to find that CD is the same as AB. AB.
Oh, I'm sorry.
And then that DE is going to be the same as AE. So we'll follow the same strategy. We'll sum forces in the y direction. So in the y direction, I have the x component of that force acting up. So that's the force in CD times the sine of 60. And then I have P acting down. So what is the force in CD? I think we've had this calculation before. Hopefully it's going to be 1.15 if we did our calculation correctly. That's reassuring. You're either making the same error twice or you did it right. I like the second one better. Then with sum forces in the x direction, I'll assume to the right is positive. So I've got negative FDE minus the x component of CD, which will be the cosine of the angle. And if you solve for FDE, hopefully you'll get negative 0.575 P. Somebody check that just to make sure. Seven down, 3 to go. We're still plowing ahead. So now I'll go ahead and put little wiggles there so we know those. Now where should we go? Can we go to our friend E now?
Yes.
Believe it or not, we can. Is it a good place to go?
No.
Oh no. Because our remaining two unknowns both have x and y components. Two equations, two unknowns. Probably not a good place to go. What about B and C?
Yes.
Yeah. If you go to B, you're going to have BC, just the x direction, and then BE, two components. So again, you can sum forces in the y direction there and pick up one equation, one unknown. And plus with our symmetry, I bet whatever we do at B, we're going to be able to do at C. And we never have to go to E if you don't want to, which I think is a good choice. So let's now do the joint at B. So there's my free body diagram. Again, I'm going to assume tension in force BC, tension in force BE, and tension in force AB. I'll put a little dotted line here just so that you know that that's 60 degrees, and we already know that that is 60 degrees. A little tight in there, sorry about that. And just so that you remember, I'm going to circle AB to let you know we know that value. So now we're getting in a little dangerous territory. If we have made a mistake here, it's definitely going to propagate into other values. So what should I do? Sum forces in the y direction. So I'll assume up is positive. So looking at the y components, both my forces have y components that are negative. So I'm going to get minus FAB sine 60 minus FBE sine 60. Well, cancel out the sine 60s. It just says that FAB is equal to minus FBE and FBE was, no, I'm sorry, I got that backwards. I'm solving for FBE is equal to minus AB, and AB is that. So this should be equal to minus 1.15p, which means that diagonal element BE is in compression, which I think sounds reasonable. So now I can actually, if I wanted to, come up here and say, well, I know that one now, right? BE, I got that one. What can I do next? Some forces in the X. So I'm going to assume, I should have done that one up there. I got these backwards, but you'll get the idea. Sorry about that. If you try to follow this at home, it'll look weird. So I'll sum forces in the X. So in the X direction, I'm going to have the X component of AB is to the left, so that's negative. So negative AB cosine 60 plus the force in BE cosine 60 plus the force in BC.
You said plus FCE, but you wrote minus.
Sorry. Thanks. So we know AB. We know BE, so we need to solve for BC. So let's see. So I plug AB in there, the negatives, that becomes a positive. BE, well, that becomes a negative. AB is a positive. So this should be a positive number. What's the cosine of 60? Is that a half? So this should be 1.15p?
0.5.
0.5? What's 0.5?
Cosine of 60 is 0.5.
Yeah. So basically it says take half of this plus half of that, and these two things have the same value. So it should come back as 1.15. Somebody check that. I don't have a calculator, so I'm just having to guess. All right, so now I've got this guy. I've only got one lone wolf left. CE. Can we go to E?
Sure.
Yes, but let's not. So let's go to C. So I'm going to try to squeeze that in down here in the corner. So there's my free body diagram for C, with the force in BC, the force in CE, and the force in CD. This is going to look a lot like joint B that we just did. It's kind of like the mirror image, right? And with our symmetric truss. Now, recall that we already have BC. We just solved for it. And we already have CD. So I'm going for CE. What's the easiest way to get that guy with one equation?
Some of forces in Y.
I think some of the forces in the Y would probably be the cleanest way to do that. Because one force does not have a Y component, so it won't contribute. So one less thing to keep track of. So we will sum forces in the Y direction. And what do we get? Well, they're both going to be acting down. And they're both going to be the sine of 60. So I'm going to have the force in CE sine 60, that's a negative, minus the force in CD sine 60. So the 60s cancel, and it basically says that the force in CE is equal to minus the force in CD, and the force in CD is So it's going to be minus 1.15. Wow. Pretty cool, huh? Now, let's just stop for a second and think about what we could do with this. So let's say P is just anything, any load. What if I say, due to constraints with the way this structure is built, the maximum tension force can only be, let's say, 2,000 or 10 kilonewtons. So what P could I put on there? Maximum tension force could be 10 kilonewtons. Where are my tension forces? The top chord. So I look at AB, and what's the force in AB? It's that. So if I set that equal to 10 kilonewtons, I can solve for P. Okay. What if I say the maximum compression force is only 7 kilonewtons? Then I find my maximum compression force, which I believe is minus 1.15, and I solve for P. Which one can I actually apply to the truss? The bigger of the two or the smaller of the two? The smaller of the two. So in some sense, that's the analysis part, but there's also a little bit of a kind of a design element in it. But I hear by the commotion that class must be over. Is that true?
Yes.
Okay. So any other questions?